This video will start Unit 7. Unit 7 is studying rational expressions and rational equations. Notice that the root word in rational is ratio, so we're going to be looking at fractions. We'll start with basic fraction skills, just simplifying a basic single fraction. I've already pulled out the greatest common factor. So you're looking for the greatest common factor in numerator and denominator. Going to divide that out, and anything that is remaining becomes the simplified expression. So what remains here is 3/4. Moving to the next one, I've already removed the common 6. I'm presenting it in factored form so that you can see what your goal is. You divide out the common 6's, and then the expression that's left, 3/8. And the next example, they both share 4. So I divide out the common 4. And then what remains is 25/6. So the simplified expression here is 25/6. Basic fraction skills. So let's step it up a little bit, adding in exponents or adding in variables. So now just to review your basic exponent properties, when the bases are the same, you simply add the exponents together, and that's what's being shown in the first example. When you have a ratio, you've got the same base top to bottom raised to different exponents. It's the top power minus the bottom power. When you've got the multiplication around the parentheses, this is the time when you multiply the two exponents together. Anything raised to the power of 0 is 1. To rewrite an exponent to make it positive, you simply write the reciprocal of the fraction. And here I've given you an example or a model definition example when the power is something other than 1 with the A. Okay, let's see what this looks like. I'm going to do this really simple. I've now thrown in some variables and powers along with coefficients that share factors. So just to make this really easy, let's look at the variables first. Y cubed tells you that you've got 3 y's on top, x squared, 2 x's on the bottom, and 2 y's on the bottom. I'm going to map this out so that it's really easy to see how things divide out. When you've got a variable top and bottom, that will divide out. Here I've got 2 y's on the bottom, 2 on top that can divide out. Anything that's left remains in the problem. So I've got 1x, 1y, and 1x top to bottom. And then 9 and 15 both share 3. So 9 is 3 times 3. 15 is 3 times 5. I've got 1y left on top, 1x left on the bottom. I divide out the common 3. So this expression becomes 3y over 5x. And I didn't use exponent properties with this. I just wanted you to see everything all mapped out just as a little review. Moving to the next example, I've already got it laid out for you. The negative sign, I'm going to think of that as a -1. 4 times 3 is 12. And then I've got the 3 x's and the 5 y's all mapped out. In the denominator, I have 4 x's and 1 y. So to simplify this, 3 x's will take each other out, and then only 1 y can be divided out top to bottom. And then the 4's can divide out. So what remains here, I've got a -1, which I'm just going to make a negative sign. Here's my fraction bar. 3 on top. I've got 4 y's left on top. And then the denominator, I just have a single x. So anything that does not divide out is left over, and they all come together to create the simplified ratio. Moving to the next example, just rewriting this so that the variable becomes positive. This is just simply 5/x. That -1 just tells you to put the variable on the other side of the fraction bar, and then the power becomes positive. Moving to the next one. Here, I chose to simplify what's happening on the inside first, simply because they share so many things. When I simplify the inside, then I can apply this square on the outside. So here to apply this, I'm going to square the x. 2 times 2 is 4, and then 4 squared is 16. So this power of 2 goes to everyone on the inside. And it's squaring, it's not 4 times 2, it's 4 times 4. Let's see what's next. Over here. Okay, so now here, 5 and 25. 5 and 25 can be simplified down to 1/5. I've got an x squared in the denominator. This negative power right here, the bases are the same. They're both raised to the power of x. When I bring this down to the other side, that 4 becomes positive. So the simplified expression here is 1 over 5, and x is raised to the power of 6. Let's see, moving on. Okay, here we go. Now, letting this get a little bit more complicated, which is where we need to be, I'm going to simplify all of these by factoring. So we'll start with the GCF factor first. And then we need to list excluded values. And then I'll stop the video and let you all practice. All right, here we go. So simplifying expressions by GCF factoring only. I'm going to copy the numerator. In the denominator, they both share 5x. So if I reverse distribute out of 5x, which means I'm dividing both members of the denominator by 5x, I have 4x minus 1 left over. This 5x on the top would be multiplied by 1. Look for what is common top to bottom. The common factor divides out, and then what's left over, just like with the simple basic fractions, the expression that's left over becomes the simplified expression here. Looking at the next one, I see in the numerator, 3 is common to both, leaving you with x minus 2. 12 is 3 times 4. Divide out the common 3, and then you're left with x minus 2 over 4. That's your simplified expression. The 2 and the 4 in this example are not candidates for dividing out. Because in the numerator, they're connected by addition, subtraction. If they were connected by multiplication, this I could simplify. But when they're connected by addition, I have to stop. All right, here we go. Next example. Let's see, the numerator, both members share 4. And then the denominator, both members share 4. And then dividing out the common 4s. And then you're left with x minus 2 on top and 2x minus 1. Notice that the members that are left top to bottom are connected by, in the respective numerator denominator, they're connected by an addition subtraction. So anything that remains is not a candidate for being simplified out of the problem. All right, let's review factoring for a minute, and then where this is headed is simplifying the ratios that are comprised of 2 polynomials. And I want to do this with you, do a few of these with you, then I'm going to stop the video and let you all practice. So just to do a quick review of quadratic factoring, it's best if you can do this mentally, especially when the lead coefficient is positive 1. So 2 numbers that multiply to 9 and add to 10. Here you would be looking at 9 and 1. And hopefully you can just go straight into the factors here, because you're going to be using these and sometimes taking the time to factor the long way. If that's what you have to do, then that's what you should do. But if you can do mental math factoring with some of these that are really simple, it will speed up the process for you. So over here, I need 2 numbers that multiply to negative 15 and add to negative 2. Since I've got the negative signs here, that lets me know that one number is positive, one's negative. Looking at 5 and 3. Since the 2 is negative, that means the larger factor is negative and the smaller factor is positive. The next example is the pattern, the difference of squares pattern. This is the x plus 9, x minus 9. Both of the members, or both of the terms, are perfect squares. So you're looking at the square root of each. This is that conjugate moment where you've got the alternating signs. One's positive and one's negative. So anytime you can mental math factor, it's going to make this process much, much easier. Giving you a few examples where the lead coefficient is not positive 1. So these take a little bit more time. You need 2 numbers that multiply to negative 30 and add to negative 7. That's going to be negative 10 and positive 3. So to review the process that we studied first semester, you then rewrite this, and the term in the middle is expressed as negative 10 plus 3. So negative 7 is written as negative 10 plus 3, and then you introduce the grouping symbols and you go through the factor by grouping routine. So here you're looking for the greatest common factor in the first pairing. And the goal is to create a match. So I reverse distribute out of 3. And then here are my 2 factors. And you just need to be able to get through this fairly with efficiency and accuracy in order to be successful in this unit. And one more example. Let's see, 3 times 9 is 27. I need factors of 27 that add to 28. I just made simple examples for you. 27 and 1. You rewrite the expression, 3x squared plus 27x plus 1x plus 9. Introduce the grouping symbols in. 3x is the common factor in the first pairing. The second pairing, it already is the match that I'm looking for, but the 3x is going to need something to come together with, and it's binomial. It's 2-term factor. So remove a 1. And you have 3x plus 1, x plus 9, and those are your factors. Now, the way that we're going to use this is we're going to simplify expressions that are ratios of polynomials. So here, I want you to stop the video and jot down what I've got written over here. It's really important to list what's known as excluded values. And excluded values are values that create division by 0. So I want you to stop the video, jot down these bullet points, and then we're going to restart the video again, and then we're going to carry on. I'll show you how we're going to pull all of this together. So I'm giving you a ratio here that we've already factored above because we're going to use this skill. So I'm going to write my fraction. I'm going to give myself my grouping symbols for my individual factors. The numerator is x plus 9 times x plus 1. The denominator is the pattern x plus 9, x minus 9. So the first thing I want you to do is factor. Then the second thing I want you to do is look at the denominator and list the excluded values. If I take x plus 9 and set it equal to 0 and x minus 9 and set it equal to 0, my 2 excluded values are -9 and +9. So x is not allowed to equal positive or -9. And that's coming from this denominator right here. So factor numerator and denominator. Look at the denominator, list the excluded values, and then the third thing you're going to do, you're going to divide out the common factor. Divide out the common factor top to bottom. So it's kind of that process every single time. So here, x plus 9, the binomial x plus 9 is common to top and bottom, and the simplified expression here is going to be x plus 1 over x minus 9. That's your final answer. That is your simplified expression right there. That's your goal. But each time you look at these, factor the numerator denominator, look at the denominator and list the x values that would create division by 0, and then analyze the fraction and divide out anything that's common top to bottom, and the factors that don't divide out come together to create the simplified expression. Let's do a few of these, and then I'm going to stop the video and let you all practice on your own. And let's see, we already factored these above. So this is x minus 5, x plus 3. And this is 2x plus 3x minus 5. X minus 5, 2x plus 3. So this is step number 1, I factored. Step number 2, list your excluded values. So listing my excluded values, I'm going to look at the denominator, and I'll take each one of these, set them equal to 0, to determine the values of x that would create division by 0. Here I'm solving a 2-step equation, so x is going to be -3 over 2. So x is not allowed to equal 5 or -3 over 2. And then step number 3, divide out the common factors. And that's your process. So analyzing this, dividing out what's common, the binomial, the 2-term binomial factor in parentheses, x minus 5 is common top to bottom. So the simplified expression here is x plus 3 over 2x plus 3. Notice that both members in the numerator denominator Everything is connected by addition, so there's no more simplifying for that problem. The 3's and the x's stay because they're connected to their each term by addition, and I can't divide those out. Okay, moving to the next. Here we go. Here's our pattern, +9 - 9. And then in the denominator, 2 can back out, reverse distribute out of 2. List your excluded values. Let's see, the only factor I'm looking at is x + 9. If I set that equal to 0, x is not allowed to equal -9. So once I've done that, go back and analyze, looking for the same factor top to bottom. X + 9 cancels out. So what's left is x - 9 over 2. That is your simplified expression. X is not allowed to equal -9. And the last example for the video here, I've given you a pattern, and I didn't do this pattern before. So this is a difference of squares. Both of these are patterns. This is a difference of squares, and this is the pattern where you have the same binomial times itself. So to do the numerator, taking the square root of each, it's 2x + 5, 2x - 5. In the denominator, 4 times 25 is 100. I'm looking for factors of 100 that sum to 20. That's going to be 10 and 10. And if you rewrite this, rewriting 20 as 10 + 10, and then introducing your grouping symbols in, removing what's common, 2x, leaving you with 2x + 5, and over here, taking out a 5 + 5, leaving you with 2x + 5, you see that you end up with the same binomial times itself, which is another pattern. And here your denominator would be 2x + 5 times 2x + 5. And both of these are patterns. One pattern is called a difference of squares. This is the difference of squares. And the denominator pattern is the same binomial times itself, the perfect square trinomial, if you recognize that. Okay, so we factored, and now we have to list excluded values. The factor in the denominator is the same, so I'll just take 2x + 5, set it equal to 0. Solving a two-step equation, x would equal -5 over 2, which means that's the value that I'm not allowed to have in the fraction because it's the value that will create division by 0. Moving back to my factored expression here, I'm going to divide out 2x + 5, 2x + 5, and then the two factors that remain come together to create the simplified expression. So through the video, I've shown you the progression of your skill with fractions, simplifying basic fractions, and then introducing exponents in using exponent properties. And I mapped this out for you, so it should be pretty easy to see how to divide these out and how to determine what's left over. And then we step it up and we get into the quadratic using factoring, which is the actual goal for this, and leading you through excluded values that create division by 0. And I'm going to stop the video now and ask you to practice this skill.